All right, so where would you guys start to cube this binomial? What's your thought process on where to start?
You want to...
Okay.
No, like, couldn't you just start by doing it 2 times?
Absolutely we can. So I can take this guy and we can break it into 2x minus 5 squared times 2x minus 5. We can absolutely do that, and I think that is a great approach because I know how to square a binomial really quickly, and then I just have to use the distributive property to get my final answer. So how does 2x minus 5 square?
4x squared minus,
4x squared.
Minus 20x plus 25.
Yes. Square your first term, multiply your 2 terms together and double them. Square your last term. All right, so now I'm going to take that trinomial and I'm going to distribute it to my binomial. So I'm going to have 8x cubed minus 20x squared minus 40x squared plus 100x, and then just the 25, plus 50x minus 125. Will anything combine? Yes. My x squareds, which are thankfully side by side, and my linears, my just x's. So what will this be when I combine all my like terms together? Start with my 8x cubed minus 60x squared plus 150x minus 125. Beautiful. So you know how we have a pattern that we follow for squaring a binomial? Square the first, multiply, then double, square the last. There is a pattern for cubing a binomial. I'm going to go ahead and write it down. This is not something that you have to know for this course. This is a nice to know, not a need to know. Squaring a binomial is an absolute must. That is a must know. All right, so if I'm going to take a binomial, a plus or minus b, and we're going to cube it. Our pattern there is my first term gets cubed. Then it is plus or minus 3 a squared b plus or minus 3 ab squared plus or minus b cubed.
I think I'll just do this.
And that's fine. Some people are curious to see this. It's fine if you want to use this. If you do learn it, that's great. You're not required. Doing it the other way will get you to the same final answer in roughly as much time. All right. So I told you guys we're going to factor and then do some more factoring today. And then after that, right before the bell, we will factor. So that's what we're going to work on today. I know, isn't everybody so excited about this? If you feel like I'm rushing, first of all, please let me know. But I'm also fairly certain that we're not going to get through everything that we need to for today. And so I am going to continue to kind of roll through some examples, but I do want to know if you feel like I'm going too fast. Okay? We're going to start off with dividing a polynomial by a monomial. What does monomial mean?
1.
Yep, 1. This is one term. Before we actually do any of these three, I want to know, what property would you use to do this? So what I have in red circled, what property would you use if I asked you to simplify that?
Distributive.
Distributive property. we are going to use the distributive property here. But instead of distributing multiplication, I'm going to be distributing division. Other than that, it's exactly the same. So I'm going to distribute division by 2x to each of my terms in the numerator. 8x to the 5th over 2x minus 2x cubed over 2x plus 6x squared over 2x. And then I have to reduce each of those fractions. If you go right to dividing and reducing in your head and you write down your final answer, that is fine. What will my first term be fully reduced? Four x to the 4th. And then we're going to have x to the 2nd, plus or minus?
Minus.
Minus. And my last term, plus 3x. Beautiful. This is still considered a monomial down here in this denominator. Why is that still considered a monomial? They are together and there's no pluses or minuses in there. Yes. Whenever we're looking at a product of two things, it is considered to be one term. We're going to distribute this guy as well using division. So 3m cubed n to the 4th over m cubed n squared minus 2m to the 5th n squared over m cubed n squared plus, and before I write down this last numerator, I'm going to go ahead and simplify that before I put it over my denominator. M squared n squared, whole thing to the 2nd power, which means what? Yes, m to the 4th, n to the 4th over m cubed n squared. So then I come in here and I reduce each term. What will I get when I reduce the first term? 3n squared minus 2m squared plus mn squared. Beautiful, beautiful. Last one here. Distribute my division. I'm not going to write down each fraction this time. Are you guys okay with that? Okay. So when I distribute to the first term, how does that reduce? Negative a squared, absolutely. And then my second term? Negative 4b to the 2nd. And my last term? 2a cubed, and then I didn't hear the power on b. 5, thank you. The problem just said divide by monomial, right? Is that last one, the way I wrote it down, in decreasing order? No. So if I wanted to put this in decreasing order, what would need to go first? 2a cubed b to the 5th. Did you move that to the front because of the power on a or the power on b? Power on a. If you have more than one variable, we do it alphabetically first and then by power. So it's the a to the 3rd that is the reason that I brought that up to the front. So then minus a squared minus 4b squared. So far, so good? All right. Let's talk about some GCFs. What are GCFs? Greatest common factors. We're talking about it by itself on this screen, but whenever we factor, this needs to be your first step, checking for a GCF and pulling it out before you go forward any further in the problem. One of the biggest obstacles, hurdles that I see, and it happens to me also when I'm not being careful and diligent, is that you'll get to a problem that you're supposed to factor, and especially with this being a no calculator course, if you don't remember to check for that GCF and you don't remember to pull it out, you can end up with some astronomically large numbers. But there is no way you're going to factor without a calculator in 44 minutes and answer the other questions on the test. So we always want to be checking for this first. What is the GCF on A? X. And that would leave me with what remaining? X minus 7. What about on B? 4xy. Which leaves me with what? 7. There we go. And what is my GCF on C? 9. A, B to the third.
Pump the brakes.
Yes, absolutely.
Yeah.
Yep.
I haven't wrote down the problem.
Yep. This is why I said, please tell me if I'm going too fast. What am I going to have left in that first term? A, B. Second term, what will I have left?
3b squared.
3b squared. And that third term?
9a squared.
Perfect. Is this in decreasing order? No. So I'm going to go ahead and put it in decreasing order. My GCF stays the same, 9ab cubed. What should my first term be? 9a squared. And then after that, it is in decreasing order, plus ab plus 3b squared.
Wait,
Mm-hmm.
so ab goes before 3b squared?
Yes,
Oh, because of the a.
because of the a. That's absolutely correct. We want to get all of our a's in decreasing power order before we look at anything that doesn't have an a. Mhm. If you left your answer the way I wrote it on top, not what I put in the box, would I count it wrong?
No.
No.
Do we get like half a point off?
Nope. I'd give you full credit. Unless the question says, make sure your answer is in decreasing order. If that's part of the directions, then I'm going to be a stickler about it, because then that's one of the things I'm looking for. All right. Let's factor some trinomials.
You really meant factor, factor, factor.
I really did. And honestly, we'll probably have to do just a little bit more tomorrow. I am not. Hey, quick question though. Better or worse than exponents? There we go.
It's gonna get worse though.
It's actually not too bad. This factoring review is actually not too bad. Some of it looks gross for a minute, but that's like one problem.
Not one problem, it's enough.
What do I always need to be looking for first?
GCF.
GCF. Check for a GCF first. Do any of the ones on this screen have a GCF? No. How do you know?
Because there is no number in front of the x.
There's no number in front of the x. So we have a leading coefficient of 1. However, somebody pointed out to me first period that that's not necessarily always enough.
The last number doesn't have a variable on it.
Last number doesn't have a variable with it. Yes. So leading coefficient is 1. Last term doesn't have any powers of x or x at all. And so I know there's no GCF. And that's true on all these. I'm still going to go ahead and write it down because this is the kind of thing that you need to get into the habit of checking for at the beginning. And the way I know when I look back at my own work that I checked for a GCF is I either wrote it down and took it out, or I made a note that there was no GCF. All right, I'm going to do my X. I don't use the area model, the box, to factor. If that's what you use, please feel free. I don't have enough room on my screen to do an area model for any of these. I need two numbers that multiply to 12 and add to -7. Yep, -3 and -4. Because my leading coefficient is 1, I can take this and write down my two factors. It's going to be x minus 4 and x minus 3. If you want to draw the box, the area model, so that you know for sure you have it factored correctly, that's fine. For part B, I need two that multiply to positive 121. Yes, add to -22. So -11 and -11, which means I have x minus 11, x minus 11. What's a better or more concise way of writing that idea? Yes, x minus 11 quantity squared. I would not count it wrong if you wrote x minus 11, x minus 11. Two numbers that multiply to 15 but add to 8. 5 and 3. So what are my two factors? X plus 5.
No, it's A.
A, thank you.
On a test, does that matter?
Yeah.
Well, here's the thing. My answer to that question depends. If you factored it and you wrote it down as x's, but in the denominator there was an a plus 5, and so you missed canceling and reducing something because you wrote it down wrong, would that hit you for something? Yes. If it's just a factor problem, I just give you this thing to factor, and I switched it up and used q instead of x, and you wrote it down with x's at the end, you showed me that you know how to factor it. And so I'm going to give you points for that. Does that sound reasonable?
Yes.
Okay.
Thank you.
You're welcome. Last one here on this screen. Two numbers that multiply to 60 but add to 19. 15 and 4. So what are my two factors then?
B plus 15 and B plus 4.
No.
B plus 15 and B plus 4. First period, we made the same problem with starting to write down x, only we got all the way down here before anybody caught the mistake in part C. You guys caught it faster. I still almost wrote x on part D, though. I'm so used to it.
I wrote X on all of them.
Yeah, like I'm not going to lose any sleep or cry any tears about that. We'll be fine. All right, let's move on to some that have a leading coefficient other than 1. What is the first thing I need to do on these? Check for a GCF, always. Does E have a GCF? No. All right. So I move on here. I'm going to multiply my A and C together. So I need two numbers that multiply to what?
12.
12. But when I add them, I get -1. What two numbers will do that? Are we sure about that?
No, it's 1.
That does multiply, or sorry, add to -1, but it multiplies to -12.
So -3 and +4.
Let's try it.
No, it's
Sebastian, I don't know how to tell you.
Does it work if I make them both negative?
No.
No? That adds to -7. Does this factor?
No.
No.
So we can just write no factor, right?
We can write down does not factor.
Don't say that. Don't say that.
Oh, the QF?
Yeah.
Negative b squared.
That's not even right.
Does not factor.
Plus or minus the square root.
Yeah, plus or minus the square root of
B
4
squared minus 4AC all over 2A.
4ac. That's what I said.
You missed it.
No, plus square root of b, and then plus or minus 4ac
He's not saying it right.
divided by 2a.
That
Yeah. That
You
is-
got there. You got there.
I got it.
Is there gonna be a point where you're gonna make us like not just put not factor or does not factor?
No, if you write down does not factor, that's fine.
Okay.
If someone says that this quadratic is irreducible, that is the same thing as saying it does not factor. Where do I start on F?
There's a square root. Not square root. Man, y'all gonna think
Yes.
of the quadratic formula.
We have a GCF of 2, so let's get that out of here first. 2 and then 7x squared plus 10x minus 8. Now I'm going to do my x where I multiply a and c. So negative 56 and 10. What two numbers do you know of that will multiply to negative 56 but add to a positive 10? What'd you say? 14 and negative 4.
I know. How are you gonna know when this?
So does that mean this is x plus 14 and x minus 4? No. My leading coefficient is not 1.
Oh, this one's so stupid.
Here is how I look at these. You can draw your area model out to factor this. I do factoring by grouping just because I don't have a lot of room on my screen.
Me in this box are right
All right.
in 7th grade.
7x squared, and then I've got plus 14x minus 4x minus 8.
And we don't get no calculator
No calculator.
for factoring at all.
Nope.
Why would you use it? What would you do?
Alright, y'all.
Hey, I don't see multiples isn't everybody's strength. 14
All right.
exactly. I wouldn't know that. I would have sat here 2,
I
4.
would have started writing it down.
Exactly.
What can I take out of the first group that I've made there?
7
7 and
x.
x. I can take a 7x out. And that would leave me with what? X plus 2. All right. I'm looking at that second group that I've made, negative 4x minus 8, but I'm keeping my eye on what I have inside parentheses, x plus 2. I want to pull a GCF out so that I have an x plus 2 left. Negative 4. X plus 2 is left. All right.
Parentheses.
These two are the same. That is one of my factors. What will my other factor be?
7x minus 4.
Yes. If you did the area model, the box, you should get the exact same thing. Do not forget to put your GCF back at the beginning. What does the F stand for in GCF? Factor. So when you're writing it down in its factored form, you need the greatest common factor to be part of that. All right? Do we have a GCF on part G? No. No GCF.
No. Because then it wouldn't get to
I need two numbers that multiply to 100.
10.
It's negative 10 and negative 10.
We are really excited about this, and we are also absolutely correct. All right. So there are the 4 pieces that I'm going to use for my factoring. Whether you use an area model or whether you use factoring by grouping, it should be the same 4 values. Here's my first group. Here's my second group. What can I take out of the first one? I can take a 2 out. I can take an A out. And that would leave me with what? 2A minus 5. That's really what I want left over when I'm done with this second group. What can I take out of the second group so that I have 2A minus 5 left? Negative 5. 2A minus 5. So what are my 2 factors then?
2A minus 5.
Yes. 2A minus 5 squared.
Wait, is this what we're doing until class ends?
All factoring, yes. We are going to move into things other than quadratics.
Why would you say that?
Because I love you guys.
You didn't have to announce that. Wow.
You love to hate us.
It's tough love. It's tough love. I want to make sure that you guys are successful in this course. And these are necessary
So
skills.
factoring's like a big part of this class?
Factoring will never go away.
Isn't that 8?
Factoring at this point in mathematics for you guys is the same as multiplication and division. Like, is that ever going to go away in operations that I ask you to do? No. Factoring can always rear its beautiful head. So,
I don't.
part H. What do I do?
Look for a GCF.
GCF. Do we have one?
Yes.
Oh, thanks, sweet Jesus. Those are large numbers. All right. So I'm going to take that 2 out.
25 and then 4, so then 2, so that's 27.
You just say numbers.
27. 27. That's my side.
Makes you look smart.
Okay.
What did you say?
She might say a number that makes you look very smart.
I said focus on the computer.
Anyway. I need to find 2 numbers that multiply to give me what?
30? No. I thought that was a 2. That's on me for real. Don't ask me that question though. I can't do that. I can't do that. 170.
Super close. You're off by 10.
180.
180.
There you go. What are you?
Can you guys tell me how we can multiply 12 and 15 quickly in our heads?
Write it down.
You could write it down. Here's what I do. I leave the 12 alone, and instead of doing 12 times 15, I do 12 times 10 and 12 times 5.
That works.
Because 10 and 5 together give me 15. And I can do 12 times 10 easily in my head and get 120. What's 12 times 5? 60. And then I add those 2. So I need 2 numbers that multiply to 180, but when I add them... Oh, sorry, that shouldn't be 19. That should be 29. I wrote that down wrong. My apologies.
What I said.
All right. Multiplies to positive 180, adds to negative 29. Twenty and 9. Both negative. All right. So let's make our groups. 12b squared minus 20b minus 9b plus 15. Make my groups. What can I take out of the first group? I can take a 4 out. Anything else? 4b. And I would have what left over? 3b minus 5. What do I take out of the second group so that I have the same thing remaining? -3. 3b minus 5. All right, so let's finish this guy up by writing down our final fully factored result. What do I get? 4b minus 3. 3b minus 5. 2 in the front. Do not forget your GCF. Nice save. Okay. Okay. We got 10 minutes left. Let's do some softball stuff. How do you guys feel about factoring a difference of perfect squares?
Oh, yeah.
Yeah.
Okay.
Yeah.
Wait, is there any other option?
I mean, not really, but we are always going to check for a GCF. No GCFs on any of these. Difference of perfect squares will factor into what kind of pairs? Conjugate pairs, very good. What's the only difference between the two factors in a conjugate pair?
Plus or minus.
Plus or minus. So how does A factor?
X plus 3, X minus 3.
X plus 3, X minus 3. I don't care about the order. And if anybody else does, they are ridiculous. What about B?
X minus 11, X plus 11.
X minus 11, X plus 11.
Hey, it's 8 a.m.
It's almost 9.
I haven't even wrote down the first problem.
I haven't even written anything down.
Can I go to the bathroom?
Yes, you may. For C and D, I will warn you, you need to watch the order that you write things down in. Everybody is so used to putting the variable first and then the constant. If you do the variable first and then the constant, you are not going to get the right answer here.
So it's
9 minus x, 9 plus x.
Yes.
Why does it matter?
Yeah, why does it?
So for 9 plus x, it doesn't matter. Is 9 minus x the same thing as x minus 9?
No.
No. So it's the difference term there that is why we have to watch our order.
Could you do negative x plus 9 and then x plus 9?
You could write down, yeah, you could do x negative x plus 9. That is equivalent. I'm not going to count it wrong. It's going to be harder to notice certain other things necessarily, just depending on the way our problem is set up. A lot of times if they've got it in a particular order that seems weird or backwards to us, there's a reason for it. Not always. Last one on this screen. 5 minus x, 5 plus x. All right. Can we do a couple more like this?
Sure.
Please and thank you. Awesome.
Go for real.
If I need to go back so you guys can grab a quick screenshot, please feel free.
You do it so well.
Also, just FYI, if we're doing these in class and I'm going too fast for you to write, I do want to know that, but if these are ones that you can look at and you know the answer to without even thinking, it's not as important that they all get into your notes. And I do also post all of the notes, so you will have access to all this information. It's not like when you walk out of here, if you didn't write it down, it's just lost for all time. Do we have a GCF on any of these?
Yeah.
No.
No. We have some very large numbers,
Guys, I haven't looked at them.
but we do not have GCFs on these guys. How is my first one going to factor?
4x plus 7, 4x minus 7.
Yes. 4x plus 7, 4x minus 7. What about F?
I was gonna say that.
2x minus 13, and then 2x plus 13.
Yes. What is the square root of 225?
15.
15. Oops. So G factors to be what?
15a minus 3b and then
Mhm.
13a plus 3.
There you go. 289.
17.
17c minus what?
20.
20x. 17c plus 20x. All right. Last thing for today, and we'll have to finish up this and some factoring by grouping practice tomorrow. We are going to factor a sum and difference of cubes. Hopefully, you guys have been exposed to this at least once in Algebra 2. And there's an acronym that helps us.
I knew that. I didn't do that.
SOAP.
Subtract.
And you guys are all sitting over there. You said you hated soap. So I'm going to sit over here, and you can stay over there.
Yeah, I am 30.
What does SOAP stand for?
I love soap.
Yep. Same, opposite, always positive.
We're bringing back geometry.
AP goes together. Same, opposite, always positive. And this is telling me about what?
I wish the class
The order of our, if I say always positive, what am I talking about?
doesn't mean that it's always going to be, it's going to be squared.
We're going to have a squared. What's in front of the squared? Plus sign. This is telling me about my signs. So when we factor a sum or a difference of cubes, a cubed plus or minus b cubed, this is going to give me a linear a plus or minus b, and then a quadratic, a squared plus or minus ab. This is different than when I square a binomial. When I square a binomial, it's 2ab. With my sum and difference of cubes, it's just ab. And then always plus b squared. So I need to know what a and b are. I need the cubed roots of each of these pieces before I can write down my terms. So I need the cubed root of x cubed, which is what? X. And then I need the cubed root of 64, which is 4. So what will my linear term be? My linear factor, sorry. I'm going after this one right here. X plus 4. How did we know it was plus?
Because positive is the same.
Yes, same sign. We were working with a sum, and so my linear has the same sign. Then we're going to write down our quadratic, and this quadratic will always be irreducible. What's my next term going to be? X squared. Plus or minus here?
Plus, not minus. because
Minus,
opposite.
because it's opposite. 4x plus 16. Let's do one more and we'll finish sum and difference of cubes tomorrow. Do I start by finding cubed roots of things on B?
No.
No.
Yeah.
GCF, which is what? 2. Let's get it out of there. So 2y cubed plus 125. So I need the cubed root of y cubed, which is y. What's the cubed root of 125? 5. So I'm going to get my GCF out at the front and help me write these two factors. I heard y plus 5. And for my quadratic factor, y squared minus 5y plus 25. We will finish up a couple more practice problems with these. We'll do factoring by grouping, and we will start 1-4. When is your 1-3 homework due? Tomorrow. Have a great one, guys.